I would say substitution is the method that most people like the most. So graphing has some positives, has some negatives, but substituting is always going to work. So will adding. That will always work too. That's the next video. So are you excited to learn about something that always works? I know I am. So here's the method. You solve one of the equations for any variable. Let's do that. I'm not going to go through the method. Let's do an example, and I'll go through the method as we're doing the example. Let's start with example 3. We're going to start with step 1, okay? So here's where we are right now. Solve one of the equations for any variable. Lots of choices. 4, actually. For me, when I look at these equations, solving this equation for y looks the easiest, because all I have to do is add x to both sides. But you could solve any equation for any variable. So I'm going to solve this for y. If I do that, I'm going to add x to both sides. And what that's going to look like is give me y equals -5 plus x. So I've just done step 1. Next is step 2. Substitute the expression for this variable. So substitute this. Specifically, the expression for this variable is the right-hand side. It wants us to substitute this in to the other equation and solve for the remaining variable. So step 2, let's color coordinate this. Why not? Step 2 will be the red step. It says y is the same thing. These red underlined things are the same exact thing. Y is equal to -5 plus x. So let's replace it. It'll be step 2 into the other equation. So now it has to be the equation that we didn't use in the blue step. We get 2x minus 5y, and we know that y is the exact same thing. So we're replacing the y in this equation. We know y is the exact same thing as -5 plus x. So we replace it. And now it says solve for the remaining variable. So now all we have to do is solve for x. Well, let's simplify. We're going to have to distribute that -5. -5 times -5 is +25. -5 plus x, or times x, is -5x. Now we have a linear equation. We need to get all the x's on one side, all the numbers on the other. So we'll combine like terms. We have 2 x's, and we're losing 5 of those x's. So now we're down 3 x's. We can subtract 25 from both sides. And if we subtract 25 from both sides, we're going to get -3x equals -24. And finally, we can divide both sides by -3 to get that x is +8. Great. That's step 2. Third step, we use green. Use that answer in the equation you found in step 1. Oh, use that answer. So use the x equals 8 and put it in. Use that answer in the equation that you found in step 1. So use it into this. I'm trying to clarify the English. It says use it into this, the equation that we found in step 1, the blue step, to find the other variable's value. All right, so we know x has to be 8. We can use this equation to find what y has to be. I'm going to say, okay, let's go over here. This will be step 3. We know y equals -5 plus x, and we know that x has to be 8. We can use this to find y. Technically, we could have used this equation too, or this equation. But the one that we're using, the blue equation, is already solved for y, so it makes our job easier. The y is going to be -5 plus x, and x was 8. The y is just +3. Great, that's step 3. Step 4 is to check our answer. So let's write our answer. So our answer, our solution, is the point x, which is 8, y, which is 3. That's our solution. Well, let's check our answer. Step 4. How do you check our answer? The solution to an equation is just all the points that make that equation true. For a system, it better make both equations true. Isn't that impressive? Yes, Yoshi, I agree. Yoshi's very impressed, okay? That was actually really loud on my end. I hope it wasn't so loud for you guys. The random loud Yoshi popping into a math lecture. All right, so we can check. All right, we can name these equations. Let's just check it. This is our first equation. Equation 1. I know I have a lot of numbers, meaning a lot of things. It says negative x plus y should equal negative 5. Is that true? Yes, it is. Negative 8 plus 3 is indeed negative 5. Good. The second equation says 2 times x minus 5 times y. That should equal 1. I'm writing very slantedly now. This one I need to do a little bit out. Is 16 minus 15, is that equal to 1? You bet it is. We did it. Hooray! Great. Let me know if you have any questions on this one. That's substitution. Now it's your turn to try it now. It's blue. Oh yeah, I noticed it was blue and I said, I don't care. Let's just have a blue problem. So let's solve by substitution. Pause the video, try it now. So the first step was to solve one of the equations for one of the variables. Well, we're done. One of the equations is already solved for one of the variables, right? We don't have to solve for y. It just says solve one of the equations for one of the variables. We've done that. Great. Step 1's already done. Step 2 was use that expression into the other equation. So looking at this other equation, we know that 4 is equal to 3 times x minus 2 times y. We know exactly what x has to be. X is y plus 3 if we want both of these equations to be solved. So then we go through and we simplify, distribute that 3. 3 times y is 3y. 3 times 3 is 9. And we'll simplify some more. We have 3 y's. We're losing 2 of the y's. Well, now we only have 1 y. You don't have to write the 1. We'll subtract 9 from both sides. And that'll give us that 1y is negative 5. That means y is negative 5. That was step 2. Step 3 was to say, okay, go back to that first equation. Right? If we know x is y plus 3, the blue equation, step 1. If x is y plus 3 and y is negative 5, well, we can use that to find out what x is. X is y, which is negative 5 plus 3. X is negative 2. Great. So our answer is negative 2, comma negative 5. And we could check our answer. It should satisfy both equations. I'm not going to, but you could. Another way you could check your answer is by graphing it. X is equal to y plus 3. And we know that 4 is equal to 3x minus 2y. Where are those equations both true? They're both true where they cross. And by George, that is at negative 2, negative 5. Just like we said. Isn't that impressive? All right. Half-hearted applause, but I'll take it. Let me know if you have any questions, and good luck on the homework problems.